Hi everyone, my name is Smithil and I am a third year graduate student at Mercer University College of Pharmacy. Today I'll be presenting my poster titled Microneedle Immunization for COVID-19 using the spike glycoprotein encapsulated in microparticles induces a strong humoral response. Firstly, to address the question of how COVID-19 has affected how my research would affect the real world, I would like to say that we are all aware of the havoc that COVID-19 has caused with more than 200 million cases and more than 4 million deaths worldwide. Although there are vaccines available which has caused reduce in hospitalization and mortality rate uh, in some developed countries, we cannot neglect the fact that COVID-19 still continues to affect most developing countries as well as some developed countries. Since, since the major drawback of currently approved FDA vaccines is the unavailability in most developing countries as it requires cold chain storage, and they mostly use invasive routes of administration like the intramuscular route of administration, thus they are non-patient compliant. Our research or our vaccine approach helps in overcoming all these issues and also has some added advantages. With this in mind, I would like to give you all a little more background about my research. Most of the coronaviruses have a very common structure where the spike glycoprotein is highly immunogenic and has mostly been the antigen of interest. And since this spike glycoprotein binds to the ACE2 receptors and helps in the entry of the virus into the cell. One of the coronaviruses that have caused an epidemic in the past decade is the SARS-CoV virus. And the spike protein of the SARS-CoV and the SARS-CoV-2 virus have very similar structures. Thus, we chose this antigen as our antigen of interest to formulate a vaccine. Apart from the advantages that I mentioned earlier, that our microparticles and microneedles help in avoiding cold chain storage, the microparticles are also more stable in nature and are better taken up by antigen-presenting cells. Moreover, our research uses innovative dosage form or approach of innovative dosage forms such as microneedles, which are needleless and painless in nature, and they help in rapid and self-immunization since it is like a band-aid patch that one can administer by themselves. Apart from this, skin is an attractive site of administration from immunologic perspective due to the presence of specialized antigen-presenting cells such as Langerhans cells. We firstly formulated our microparticles using PLG as a polymer and using double immersion method for the spike glycoprotein and adjuvant groups. And these microparticles were assessed for immunogenicity in vitro using dendritic cells. The microparticles were incorporated in microneedles and were formulated according to the following method, and they were characterized for visual characterization using SEM, where we found the microneedle height to be about 500 micrometers. The microneedles were then administered to a murine model using the following vaccination timeline, and serum samples were collected bi-weekly, which were analyzed for the presence of antibodies. Our results indicated that our vaccine microparticles with the adjuvant groups were able to induce immunogenicity with the presence of high nitric oxide in vaccine plus adjuvant groups as compared to the cell group, and the presence or the expression of autophagosomes in antigen-presenting cells in vaccine plus adjuvant groups. This is a quantitative analysis of the same, and this is a qualitative analysis of the expression of autophagosomes, where you can see the spike microparticles with the adjuvant group express the highest number of autophagosomes as compared to the no treatment and the spike suspension or the bland group. Further, these microparticles were also able to induce antigen-presenting molecules or express antigen-presenting molecules and their co-stimulating molecules in vaccine plus adjuvant groups as compared to the cells-only group. This indicated that these showed promising results that a vaccine would be able to induce an adaptive immune response if given in vivo. And that was observed with the presence of antibodies. As you can see here, you can see here there is conversion of serum IgM to IgG in vaccine plus adjuvant groups, and also by the presence of IgG subtypes of serum IgG1 and IgG2A in vaccine plus adjuvant groups. With this, I would like to conclude by saying that we were able to successfully formulated spike glycoprotein microparticles and microneedles loaded with these microparticles, and the microparticles were found to be immunogenic upon in vitro analysis. And we were also able to see an antibody-mediated immune response by these microneedles, which had the microparticles. With this, I would like to thank you all for listening to my presentation.